everyone, so today I'm going to be talking about analytic geometry. And analytic geometry is something you've probably learned, but it's just never been formalized for you. You've learned some different parts. We sometimes like to refer to it as coordinate geometry. Now, what you probably think of when you think of geometry is you think of figures, triangles, rectangles, circles. But once we take those figures and we put them in the coordinate plane, we are talking about the geometry of the coordinate plane. And here's an example. I took this triangle, placed it in the coordinate plane, and I gave two of the vertices points. So those vertices can help me find, if it's a right triangle, can help me find this point right here. You have to remember that horizontal and vertical lines, we just can count along the axis. So if I know that this length is a horizontal line, then I know that no matter what point on the x-axis, it won't change. So I know that this point right here on the x-axis is 3, and I know that this point on the x-axis is -1. So if I'm looking for the coordinate of C, it's going to be, the x-coordinate is going to be 3. All right, what about the y? Well, it's the same thing along the y-axis. If I know that this y-coordinate here is 5, and I know that this y-coordinate here is 2, well, the distance between them will be the same distance as this length. So from 2 to 5, 5 minus 2 is 3. So I know that this coordinate, or this point right here, is 3 units. So the coordinate point here would be 2. Okay, now I know that the length then, if I wanted to count the length across, if I'm going from -1 to 3, I know that this length is 4. So if I asked you to find the length of the hypotenuse of the right triangle, you could now use the Pythagorean theorem. You could do 3 squared plus 4 squared equals, we will call that d, the distance squared. Now, some of you might be saying to yourself, oh my gosh, that's a Pythagorean triple. The 3, 4, 5 Pythagorean triple. Others may not. So if you didn't recognize the triple that we see there, you can square 3, which is 9, square 4, which is 16, add 9 and 16 and get 25, take the square root of both sides and get d really equals plus or minus 5, a positive and -5, but because we're talking about length, we're only going to look at the positive answer. So that's like an idea of what coordinate geometry can be. Now, coordinate geometry also leads us into formulas, some formulas that can help us within the coordinate plane. The most basic one that you've probably learned is the distance formula, if I want to find the distance between 2 points. Now, when I write the point x1, y1, all I'm doing is giving some coordinate point a name. And if I use 1 here and 1 here, it's the same coordinate. I could call it x2, y2, x3, y3, but I would never do this. That would be bad, okay? So you always want to make sure it has the same name. So while in the last example I used the Pythagorean theorem, the distance formula is derived from the Pythagorean theorem in the coordinate plane. So if I want to find the distance between these 2 points, -1, 2, and 3, 5, just like the last example, I can call either point, I can give each point a name, x1, y1, and then x2, y2. Now, at some point you have learned this, so this is a review, and which is why I'm not showing you exactly where it's coming from. But the distance formula is d equals x2 minus x1, so we subtract the x's and then we square them. We subtract the y's and then we square them, and then we take the square root of it. And it should kind of look like, if you think about the Pythagorean theorem, it's derived from the Pythagorean theorem, so it really does look very similar to it. One step earlier, so d equals the square root of a squared plus b squared. All right, so how do we use it? We plug everything directly into the formula. So d equals the square root of x2 minus x1, and it really doesn't matter the order you do, so -1 minus 3 quantity squared plus 2 minus 5 quantity squared. So D equals -1 minus 3 gives me -4. -4 squared is 16. 2 minus 5 is 3. 3 squared is 9. Square root symbol is an order of operations, is a grouping symbol. You have to do each of these pieces first. You have to add them first before you take the square root. So that's going to give me D equals the square root of 25, and that would give me a distance of 5. So you can either, using the coordinate geometry, you can either use the Pythagorean theorem or the distance formula. Another formula that we want you to know, prior to geometry that you've learned in algebra is the midpoint formula in the coordinate plane. Again, more coordinate geometry. The midpoint of a segment in the coordinate plane basically is the average of the x-coordinates. That would give you the x-coordinate of that point, and the average of the y-coordinates. Now remember, average just means take the items, add them, and divide by the number of items you have. Well, if I'm trying to find the midpoint, the average of 2 points, I'm always going to be dividing by 2. And you can see clearly where that formula is coming from. So if I want to find the x-coordinate of the midpoint, xm, ym, m meaning midpoint, I'm going to add the x's, so -10 plus 2 divided by 2. That's going to give me the x-coordinate of that midpoint. So that's going to give me -8 divided by 2, which is -4. And if I wanted to find the y-coordinate of that midpoint, I do the average of the y's. So -4 minus 8 divided by 2. Now I'm adding negatives, so keep that in mind, which is going to give me -12 divided by 2, which is -6. So this coordinate of that midpoint is -4, -6. And so that's how you can use some of these formulas and coordinate geometry to find distance and midpoint in the coordinate plane. All right, guys, hopefully that was a good review for you. It's something you can always refer back to. Have a great summer.